Hi, I'm Adolph Oliver, and this is a video clip about solving systems of linear equations by the elimination method. Now, elimination is the second way to solve systems of equations to get the exact answer. Remember the two algebraic methods, substitution and now elimination. Elimination handles equations that have more difficult coefficients. So many times if you have a messier problem, this is what you want to use. Now, to make the elimination method work good, you want to have both the equations in standard form, which means x and y to the left. Now, that would look just like this example right here. X and y on the left, x and y on the left, plain number on the right. Now, sometimes to make the elimination method work, you'll have to multiply one of these equations, or sometimes both of them, by numbers such that when you add these equations together, okay, combine them together, one of the variables is eliminated and you get the solution for the other one. Well, take that solution, plug it back into one of the original equations, and you can use that to get the full solution to the problem. Let's look at this beginning guy here because you're not going to get this lucky this often. Notice that if you were to combine these two equations together, and that's what we're going to do right here, the x's will just automatically knock each other out. You got negative 10x plus 10x. Usually you have to do some work to get something like this to happen. But if you got a situation like this, you say, thank you very much. Minus 10x and plus 10x knock each other out. Combine the y's. I got negative 10 and negative 8. That's a total of negative 18y equals, combine 6 and 30. That's 36. Okay, divide both sides by negative 18. Here we go. And I get y equals, there's a single minus sign. 36 divided by 18, I think, is 2. So there's half your solution right there. Now, like I say again, don't expect to have this happen too often. We're not done, of course, here. We got to figure out what x equals. And so you can take either one of the original equations. This second one looks like the numbers are a little bit lower, so I'll use that, the coefficients in front here. You'll get the same answer either one, but you're always looking to see if you can, save yourself a little bit of extra work. So it's y I know is negative 2, so I'm going to rewrite this equation. 10x minus 8 times, there's a hole for the y, equals 6. Well, here's what we got. Y equals negative 2. So let's put this all together. I've got 10x minus 8 times minus 2 is plus 16 equals 6. Okay, well, let's keep going here. Now we got to do to solve for x. Jump to plus 16 to the other side, becomes negative 16. So I get 10x equals what? Negative 10. Divide both sides by 10. Here's half my solution. X equals negative, and 10 divided by 10 is 1. So there we go. We already got the y value up here. Here's the x value. So our system solution, if you were to plug these into both these equations, it would solve both of them. The x value is negative 1. The y value is negative 2. Okay, well, this is the elimination method. But you're not going to be lucky to have a nice situation like this. You're usually going to have to do some work. So here we are. Let's look at this system right here. Two equations again, and two unknowns, x and y. Now, one of the first things we mentioned to you was that the elimination method works best if you have it, if you have the equations in standard form, which means you want to have the x and y's on the left. So this first equation right here to clean it up. I'll jump the x over. This is plus 3x. It'll go over as negative 3x. Then I got negative y equals 11. Okay, that's standard form. Now, the second guy, we got to put him in standard form. Notice the only problem here is that we just have to interchange the sides, and I'm going to make the variables line up under each other here to make it easier for us. So the minus 7y and the minus 8x go on the left. I'll write the minus 8x first, and then the minus 7y, and then the guy that jumps back over to the right is the negative 14. Okay, so here we are. We put them both in standard form, and you want to do this so you can see exactly what your next step has to be. Notice that nobody's going to just exactly knock themselves out. We got to do a little bit of work here. Now, what you often look at is the LCM for these to figure out again which is the easier to eliminate, the x or the y. Notice that the lowest common multiple we'd have for the x's that we could do would be 8 times 3. So the LCM would be 24. Over here on the y's, I got 1 and 7. The LCM is 7. So the y's have the lower LCM. We'll go with the y's. Now, I got negative 7y here. To be able to cancel that out, I need to make this positive 7y. Well, what do I have to multiply negative y by to make it positive 7y? Got to multiply it by negative 1, not negative 1, negative 7. Okay, so here it goes. I'm going to indicate it like this. I'm going to take this equation and multiply everybody by negative 7. Here we go. Negative 7 times negative 3 is positive 21x. Negative 7 times negative y is positive 7y. Negative 7 times 11, negative 77. Now, I'm not going to change this second guy, so I'll just indicate I'm going to multiply him by plus 1. That doesn't change anything because I got exactly what I want, so I don't want to change anything. Negative 8x minus 7y equals negative 14. Okay, notice we had to doctor up one of the equations. We multiplied through by negative 7. Let's double check this. Negative 7 times negative 3 is plus 21x. Negative 7 times negative y will give me plus 7y. And negative 7 times 11, negative 77. Okay, looks good. Now, we only had to doctor one up because the other guy was all set. Notice now the y's knock each other out. So I got 21x minus 8. Let's see, what's that going to be? I guess positive 13x, is it? Okay, equals over here. Well, we're combining this. It's all negative, so 7 and 4 is 11, carry the 1. 7 and 1 is 8, and 1 is 9. So here we go. Positive 13x equals negative 91. Well, let's divide both sides here by positive 13. Here it goes. The 13s go out. Now let's see, what does this? I've got a feeling this is probably goes into this 7 times, huh? So x equals, there's a minus. Plus and minus give me a minus. Let's just double check this. 13 times 7. The reason I was guessing 7 is 3 times 7 gives me 21, and there's a 1 here. So 3 times 7, 21, carry the 2. So yep, that's it, 91. So what it is 13 goes once here, into 91 it goes 7 times. So x equals negative 7. There's half the solution. Okay, well now we can use any of the original equations. The one that probably is the best set for it is this first guy. we've got negative y equals 3x plus 11. Now let's point this out to you. This is one of the original guys up here. Okay, negative y equals 3x plus 11. You could use either one of these, but notice the numbers are higher in the second. So this one looks like the nicer possibility to work with. Okay, rewrite it, make a hole for the x. Negative y equals 3 times, here's a hole for the x, plus 11. Well, the x is negative 7. So I got negative y equals, what do we got here? Negative 21, I think, plus 11. So negative y equals, let's see, negative 21 plus 11 would be, I think, negative 10, huh? Okay, so divide both sides by negative 1 here. And what do we end up with? Y equals, the two minuses give me a plus. So it looks like y equals 10. Okay, there's our second solution on this. Okay, so what's the system solution? Just both of these guys combined together. The x is negative 7 and the y is positive 10. There's our system solution. Okay, well, the elimination method is designed to work with things that are a little bit messier. Let's see, we're still not too bad on this one. Okay, here we go. Notice, again, both these guys are in standard form. That's the way you want them to be able to use the elimination method. And I've got the variables lined up. The LCM here, the first number, the multiple of both these guys it hit would be 45 for the x's. But looking for the y's, it would just be 6, and one of them's at it already. So here's what we're going to do. We're going to take this first equation and leave it the way it is. 5x minus 6y equals 22. Okay, the second equation, if it's going to cancel out the y's, has got to be changed to plus 6. Well, what do we have to multiply negative 3 by to change it to plus 6? I think it's negative 2, isn't it? So if we multiply this guy by negative 2, negative 2 times negative 9 is positive 18x. Negative 2 times negative 3 is positive 6y. Now don't forget to multiply all the way across. Negative 2 times negative 12, well, minus times minus gives me plus. 2 times 12, 24. Okay, here we go then. Let's quickly double check. Negative 2 times negative 9, positive 18. Negative 2 times negative 3, positive 6. Negative 2 times negative 12, positive 24. Okay, look good. Now, combine these together. Notice the 6y's go out like we designed them to do. So I end up over here with 23x equals, well, let's see, what do we got here? Is it 46? Okay, divide both sides by 23. Okay, looks like we got x equal to 46 divided by 23. I think it's just 2, isn't it? So there's half our solution. Okay, let's see, who looks like it'd be easier to solve for y here? Don't make a lot of difference, but maybe this guy has slightly different numbers overall, the second one. So let me rewrite him back down here. And remember, it's x that we're going to solve for. So negative 9, here's a hole for the x, minus 3y equals negative 12. Now what I meant was we got the x that we're plugging in. So that's why I made the hole for the x. Now, what are we putting in for the x? We got x equals 2. Okay, so now let's go and multiply this out. See what we got. Negative 9 times 2, negative 18, minus 3y equals negative 12. Okay, minus 18 goes over as plus 18. So minus 18 to plus 18. Okay, I move that. I got negative 3y equals, okay, here we go. Negative 3y equals, well, let's see, I guess it's going to be what, positive 6? No, not, yeah, it's, plus 18 and minus 12. Positive definitely wins, and by 6. Okay, well now, to get y, let's divide both sides by negative 3. The negative 3's cancel out, so y equals, there's a single minus sign, so it's negative. 6 divided by 3 is 2. Okay, so there are the two parts of our system solution. System solution, okay, x equals 2, y equals negative 2. Okay, well, let's see what we got coming up next here. Here we go. Here's another system. Look at this one. Both of them are in standard form. That's nice. But now, who are we going to try and eliminate? Well, let's see what we got here. The LCM between 4 and 6, I think it's 12, isn't it? That's the first number they would both hit, yeah. The LCM between 5 and 7 would be 35. So we definitely want to work on eliminating the x's. That'll keep the number smaller. Now, you could go and eliminate y. You'd just be working with larger numbers. If you're careful and didn't make any mistakes, you'd be fine. Okay, here we go. We got to convert both of these guys to 12. Notice one of them is negative already, so I could make this negative 12, and the other's positive, so I could make it positive 12. So let's plan on doing that. Okay, so I want to make the negative 6 negative 12. Remember, 12 is our LCM we're trying to hit here. So I'm going to multiply it by 2. Now, everybody here has to be multiplied by 2. Be careful that you do that. 2 times negative 6 is negative 12x, plus 2 times 7 is 14y, equals 2 times 27. I think that's 54, isn't it? So 2 times negative 6, negative 12, 2 times plus 7, plus 14, and 2 times 27, 54. Okay, now, this second guy, we had to change to positive 12. Remember, we got negative 12x already here. So we got to make this positive 12. And it's positive already, so all we have to do is multiply by 3. 3 times 4 is 12x. 3 times negative 5 is negative 15y. And 3 times negative 19, well, it's going to be 19. And then I think it's 57. Let's double check this. 3 times 4 is 12, so plus 12x. 3 times negative 5, negative 15y. And then 3 times this, well, it's going to be negative. And let's see, yeah, I think it's 57. Okay, well now notice we had to doctor up both of the equations here. And this is a common thing that you have to do with the elimination method. But now look at this, the x's go out. So what do I end up with? Plus 14y minus 15. Looks like I got negative y. You could put a 1 there if you wanted. Equals what? Negative 3 it is. So divide both sides by negative 1. And we get y equals, the 2 minuses give me a plus. So y equals plus 3. There's the first half of my solution. Okay, who are we going to pick to get the second half? I think the second equation definitely has the smaller number, so let's do it. Notice you'd never use any of these guys you doctored up because they definitely have higher coefficients. You'd be making more work. So take a look at the originals and see which one looks the easiest. Now remember, we know what y equals. So I'll be making a hole for the y here. So as I rewrite this, it's going to be 4x, okay, minus 5y, well, I'm going to make a hole for the y, so there it is, equals negative 19. Okay, y equals 3. So here we go. 4x minus 15 equals negative 19. Okay, minus 15 goes over as plus 15. So I've moved it. I've got now down here 4x, okay, equals minus 19 plus 15 is negative 4. Well, divide both sides by 4. The 4's cancel out here. Looks like x equals, well, it's going to be just negative 1. There's a single minus sign. 4 divided by 4 is 1. Okay, again, what's our system solution here? Well, our x value is negative 1, and our y value is 3. Okay, let's now take a look at another example here. Oh, you could probably see trouble coming on this one. Okay, this is what you look for. Notice there's a common ratio between these. If I multiply this second equation by negative 4, negative plus 2 times negative 4 is negative 8x. Negative 2 times negative 4 is plus 8y. Negative 4 times 2 is negative 8. These are the same equations. This is going to be an on top of case. And again, what we'll see as we solve this is that the variables will disappear on us. Okay, well, here it goes. Both these guys have the LCM of 16. Not surprising. And we can eliminate either x or y here. Let me just eliminate the x's here that are out in front. So let's see. In fact, it's not going to be 16. It's going to be 8 on both of these guys. And so guess what? The negative 8x is already where we want it to be. So I'm just going to take this guy and copy him down. Negative 8x plus 8y equals negative 8. Okay, now, since this is negative 8x, I've got to make this positive 8x. What do you have to multiply 2 by? Well, it's going to be 4. So 4 times 2x is positive 8x. 4 times negative 2y, negative 8y. 4 times 2 is 8. Okay, here we go. Now, notice we wanted to eliminate the x's. They sure did. But look at the other problem. The y's also eliminated. So what am I left with on the left side? Just 0. Look at the right side. Negative 8, positive 8, that's 0 also. So once again, you have no variables. Okay, they all disappear. That means you got one of the bad cases. Okay, so what you do then is you look at what's left. Okay, if that is a true statement, okay, if it is true, then that means that you have the same y-intercepts. Doesn't mean the intercepts are 0, it just means they're 0 distance apart. So you have the same y-intercepts, and so the bad case with the same y-intercepts is the on top of case. Okay, and officially here you have infinite solutions. Okay, so that's what you'd put down for the answer on that. Now, I should point out to you that if you ended up over here with a false statement, okay, like, let's say, let's put like here, L-I-K-E, there we go. Like 4 equals 0, that's definitely false. Then that means you have now different y-intercepts. And by the way, the y-intercepts, what's the difference between this? It's 4. The y-intercepts will be 4 apart, but you don't know the exact value of them, only if they're 4 apart. But that's all you need to know, because if you have a bad case, you have no variables here, and you have different y-intercepts, then that means you have the parallel line case. It's not what we have here. Our result up here was true, so we had the infinite solutions, the on top of case. But if you ended up with a false solution, you have parallel lines, and of course, in that case, there would be no solution because they don't cross. Okay, well, here we go. Variables disappeared on us. So if these equations came from a real problem, you goofed. Better go back and work on the equations. And again, since the variables disappear, it's one of the bad cases. We look at what's left. If it's a true statement, then that means that the y-intercepts are the same, and they're on top of each other, and we have infinite solutions. That's the answer to this particular problem. Okay, let's look at one last example here of the elimination problems. Here it comes, and this points out something else that you'll bump into at times. Notice the first equation up here, they're both in standard form, but this guy's got some fractions. Fractions are messier to work with here to figure out how to clean this up. So the LCD, of course, here is just 5. And I'm going to make a fraction out of the guy on the right by putting a 1 underneath. And so what I'm going to do is multiply each and every term on both sides by 5. Now, this is just cleaning up this first equation to get rid of the fractions to make it easier. 5 goes once here and a 5 once there. 5 goes once here, 5 once there. The last guy over here, we already have a 1 downstairs, so the full 5 remains. So here it is. This is the equation now, cleaned up. 1 times 1 times x. So we have, I'll put the plus in here to rub it in, plus 1x. Plus 2 times 1 times y, so plus 2y equals 2 times 5, which is 10. Okay. Well now, here we go. The second equation was perfectly fine the way it was. The first one we cleaned up. Here it is. Now, let's take a look. The LCM here is going to be 7 for this guy, and 7 here. Now, that gives you a little hint of some problems coming up. But let's say we get rid of the x's. So I'm going to leave the first equation the way it is. Negative 7x minus 14y equals negative 14. And now I've got to change the second guy to plus 7. Well, we got 1 here. The only way you get a plus 7 is multiply by 7. 7 times plus 1 is plus 7x. 7 times plus 2 is plus 14y. And 7 times 10 equals 70. Okay, here we are. We wanted to get rid of the x's, so we multiplied the second equation by 7. So I got negative 7x plus 7x. Those definitely zero out. But then say, oh, look what happens with the y's. They're gone also. So we got a bad case here, no variables. Let's see what we ended up with over here. It looks like positive 56. Huh? Okay, so once again, here's the situation. We have no variables. Okay, so that means we have a bad case. Okay, now remember to figure out which one of the bad cases it is. And we only have 2. Okay, parallel lines and the lines on top of each other. You look at what's here. Now, as we pointed out in the last problem, if this is false, which it definitely is. I mean, 0 is not equal to 56. So that being the case, that means you have different, okay, y-intercepts. Now, it doesn't tell us what the intercepts are. You'd have to solve the equations to get that. But different y-intercepts. So what's the bad case with different y-intercepts? Well, that's the parallel lines. And what's the official answer when you've got parallel lines? Okay, well, the official answer is no solution because they don't cross. So there you go. Parallel lines, no solution. Well, as we've seen, you can have bad cases here. We saw what it looked like when we did them by grafting, either parallel lines or lines on top of each other. But if the system is bad, it's going to be bad no matter what method you use to solve it. So substitution elimination, how you know you've got a bad system is the variables disappear on you. Okay, you look at what's left. If it's a true statement, the y-intercepts are on top of each other and you got the on top of case, infinite solutions. If it's a false statement like this one right here, then that means you have different y-intercepts. It's the parallel line case, and officially, then you have no solution.